All right, so today me and Jay will be talking about GitHub Actions and in more general CI/CD.
Yep.
So today we more specifically want to cover what CI/CD is and then go over how we use it in Sailbot Workspace, both like how to use it as you interact with it in your PRs, as well as if you wanted to create it in your own personal projects, what that would look like. And lastly, we'll cover the GitHub Actions that are currently in Sailbot Workspace. So first, an overview of CI/CD. CI stands for continuous integration, and this encapsulates an automated framework for building your code, linting. So that's a type of test which checks for style and ensures that the code base follows certain guidelines in that sense. And then tests for correctness, which would be our unit tests that each subteam is creating, as well as integration tests, which we are working on. Besides continuous integration, there's continuous deployment, CD, and this is how you would take the code that you're developing on GitHub and publish that to the production environment. So what that would look like in the case of a website is you publish it to some sort of website that it's exposed to the internet and everyone can access. So why use CI/CD? So CI/CD is kind of an automated and standardized way of running these tests and deployments such that you can always verify that everything is, so that you can make iterative, reliable changes. So for instance, if you're working on a project on a team, everyone has slightly different coding styles, and not everyone will know exactly what each line of code is doing in the repository. So that's one case where it'd be valuable to use CI/CD, because this would run through some preset checks in style and correctness just to make sure the basic errors are caught. For example, if you change a variable name in a function, or argument name of a function, and you don't change it in where it's every instance where it's used, that might be something that's hard to catch manually. But if you push it to GitHub and that runs the automated tests, that's one thing that could catch pretty easily. So that would be an example of a syntax bug, as well as integration. For example, if someone changes a field in a message in custom interfaces, which multiple subteams uses, this would catch instances that weren't updated to that correct name. So what is GitHub Actions? GitHub Actions is a CI/CD platform. So it's one offering that can do CI/CD. And in particular, GitHub Actions is the easiest way to integrate with GitHub repositories, which we're using. And just in general, GitHub is the most popular host for Git. This is for open source code. So a lot of things that you can find are hosted on GitHub, as well as a lot of companies host their own version of GitHub. So these, like knowing GitHub Actions and working with GitHub in particular is a pretty extensible, like valuable skill. So just explaining this diagram here is kind of a high level overview of what a GitHub action looks like. So there's some sort of event that triggers an automated job to run. So this could be, for example, when you make a push to a pull request, that could be an example of an event. Or if you merge a commit into the main branch, that's another example of an event. So triggered on this event, this will start a job on a runner. The runner is like its own isolated environment, and then you can perform certain actions or steps within this job. And with that, I'll hand it off to Jay.
Yeah, so the ways we could interact, so to start off with, the ways we can interact with the CI or the continuous integration mainly is like in Sailbot Workspace, we tend, especially when we deal with pull requests, we tend to see this section where it will tell, which will run all the different tasks. and it will, and so on. One of the key things that we can see is, like, if any of these tests fails, we can always look at the details and look at where the errors can be. And I remember in the case where Patrick and Jamin had his issue, sometimes the errors tend to be not caused by the code itself, but right now it is caused by a code. For example, in this linting from Flackade, there's like an error caused by this linting issue, I guess. Yeah. But in what I was saying initially was like, sometimes if you want to, if there was no issue with the lint, or it's just some random bug, you can always go back in the test and always, what do you call, rerun the jobs. So if I go to, let's say, actions out, and let's go to this one. So you can always rerun these jobs, and you can always rerun one of the failed tests. And if you rerun these failed tests, it may fix that bug. But in general, it's most likely to be the problem. There may be a problem with the code itself. Another way of like testing your code is like going onto the code workspace. And so you can just, and in one way you can always do tasks. Is it right? Oh, that's not. Okay, so you can always run tasks, and you can run the test task. And when you run a test task, it will go through all the processes and like rebuild and test everything up. So that's one way of saying, that's one way of looking at the CI, or looking at all the tests that are running on your local environment. Another way is using the extension, the testing extension, and just seeing what errors is there. And to see the outputs as well, especially from testing, you can go to the output tab here and go to the test extension portal somewhere here, if I can find it, Python test log. And you can see all the errors or all the test cases that has failed or not, which is currently being failed. So that's one way of looking at it. So that to basically set up a GitHub action or a CI, continuous integration, we can look at the software quiz sample solution code. And this is a basic setup of how a GitHub action is. For example, if I look at python.yaml, when this file contains the name of, so this is a Python tests, and that's the name. And this code, this action or the CI will only run if it's been pushed into the master branch, or there's a pull request that's been made. So that's where you can see when you look at a pull request, you can see those CIs written. So that's where this is initiated. And so there's these jobs. Within these jobs, there are different kinds of tests. So before we do that, we need to set up the environment or the runner, which normally we tend to use Ubuntu as our environment. Within those, there are different steps. So in setting up, so you have here is where you do all the setup, where you can say, check out this particular repository. So in this case, within the software quiz repository, you just look at that particular repository that you're looking at of this repository, and then you check out that particular branch that is being made as a pull request, and set up the Python scripts. So after setting it all up and looking at where to look at, you set up the Python environment and so one of the way we say it is like uses is actions setup Python at v4. That's just a statement that comes from GitHub Actions, where you tell them, we want in the Linux environment, we want the environment to be in Python, and we send a parameter which is with width, as we want the environment to be within version 3.10, and then we start going through the process of. So one more key thing is the name here is like check out repository setup Python 3.1 install dependencies is what you will be seeing in the logs when you're running the action. And these run commands or uses are the things that is actually being run on the Linux. or especially run. So this will say like pip install all the packages and ensure that's running. And then this final command, which is linked with flag 8, you just run a specific command, flag 8 command, and that will run. And you'll get an specific output. So that's basically basic setup of how you set up a linting continuous integration job. And similarly for C, it's a similar setup, but it's much more simple. It's just same. It's only going to get triggered on a branch or a pull request, as it says here and here. And the same setup as in Ubuntu and checkout repository, and check out on that particular pull request branch. And then interesting enough, there's something called submodules. This basically says that if you can't find the branch, or if you can't find the particular file, then continuously go through each and every single directory and find that particular file that you're interested in. And that's what submodules does. And then you create what do you call? You build the C, and then you just test it out. So a cool feature within
Can I first add something
Sure.
to that section before we get to the hidden tests?
Sure.
So if you notice, this matches our diagram over here. We have an event, runner, and a job, right? So matching that to our configuration file, which goes in .github workflows. So this is fetched automatically. If you put a YAML file in here that's valid, it will automatically, GitHub knows to read that and to create a job for that. So these are the events that this workflow runs on, and then these are the jobs. And for each job, runs on sets up the runner. And then for the steps of the job, the two main steps are either uses or run. So run is pretty simple. It just runs your whatever CLI command that you want to run. So if it's something super simple, like running PyTest, you can run this in your terminal, and that should be the exact same output as what you get over here. And then the other one is uses. So uses is using some other action that someone wrote. So you can search up these pretty easily just by copying, pasting this name, searching for it. So each of these has their own GitHub repository. And if you go here, often in the README, they'll document what are the different arguments that you can use and the most popular use cases. Yeah, so for example, here you can see some arguments that are often used are setting the Python version of what you want to use, as well as a cache for the pip dependencies, just to speed things up. Here. Yes, and this last part is just specifying the major version, in case you want to pin the version that's being used to ensure that it runs the same every time and what you expect, and you don't get surprised by other updates. The last part that's kind of interesting is how GitHub Actions knows whether you passed or failed. Like, how does it like make that X or the tick? And that is a product of the return code of the command that you use. So if Flake8 and PyTest automatically do this, if there are no errors, it will return 0, like exit 0. That's a command that you can use. That means return with no errors. However, if there are errors, it will exit 1, which lets so if GitHub detects that there's an exit 1, then it will flag that as a failed job. So if you're using a default linter or a tester, this is all set up. But if you're writing your own, then you might want to know that. All right, you want to talk about the hidden tests?
So for the hidden tests, I'll just demonstrate the functionality. So what the hidden test basically does is you can take whatever repository that has been cloned. So let's say I made a sample software quiz repository, and I made some test cases, and I made some example code, and I want to test using our hidden tests within our solution bank. So what we can do is, if you want to run a workflow, we can set out own a repository such as J's repository, or I cannot type. So J's software quiz repository, and it will extract that particular cloned repository and then run the Q test or the Py test on it, and we can run that off. The way we set it, the way it was set up was similarly, we have an event. So when on workflow dispatch, we can say set the inputs of the repository. So as per default, it will be, as you saw, it was UBC Sailbot software quiz, but we can always change that. And there's these required and types. And required is like, if this is always going to run true, to my understanding, just correct me on this, but basically required true is saying that unless specified, it is always going to return this default UBC Sailbot. And if you specify something, this will be it'll overwrite whatever has been returned as default. Am I saying that correctly?
Required true means that you have to specify it.
Yeah.
If it's false, then you don't have to specify it. Yeah.
So for example, for Q test, you don't have to specify this. You don't have to specify the Q test. As that's why it's a checkbox, and you don't have to always specify whether you want to run PyTest as well, but it's always defaulted as true. Similarly, you have to run through the jobs. First thing you have to set up the environment. So if the Q test is true, then you set up the environment, Ubuntu environment. Then you run this through the steps and setting up the repository, looking at and this is coming from the external GitHub to look at the particular branch, and then you go through the repository and the source of the repository, and then look through it. And so it goes through a variety of different steps, and at the end of the day, you basically run the test cases that's hidden within the solution bank against the candidate's code and see whether their code is running correctly. And if you run through it, similar for PyTest, you'll get an output if all the tests are good. If they run if all the tests, if the code can run through all the tests and it's valid, then it'll be positive. Otherwise, it will be negative. And as the basic setup for Q test is the same for PyTest, where you go through setting up the event, looking through the repository, getting the branch, and then extracting the particular source file, and then not extracting the source file, but running the test command for test standard calculation and source and checking it. And yeah, and you have to also install the dependencies and run PyTest. So
I just want to emphasize the differences between the hidden tests and the other tests. This PyTest runs in the current repository, and it's simple. Yeah. And the event is when you push to master or you create a pull request. That's the event. But for hidden tests, the event is workflow dispatch. So you have to manually run it in this tab, in the actions tab. Then you go to hidden tests, and then you click run workflow.
So another thing I realized is previously, when we did not have a mono repository, you would have to go through like if this is local path 1, you have to extract the files, the workflows from Sailbot Workspace into the, let's say, local pathfinding repository and run those. Mm-hmm. So you have to go through, you have to like have this kind of setup in a similar sense.
Yeah.
And then be able to run that automatically.
Yeah.
Which is quite tedious. So thankfully, we're in a mono repository.
The difference in the jobs themselves is this if condition. So if this is false, it will just skip that job. And the difference in cloning is rather than the default way that this works is that it clones the current repository, but by specifying some arguments, you can clone some other repository in a different directory. And this, of course, you can find all these arguments in Actions checkout. Yeah. Anything else that you want to add for hidden tests?
I don't think so.
Okay. Let's move on to the different CI that we have in Sailbot Workspace. Again, this is defined in the .github workflows directory, and we have 3 different files. We have build images, docs, and test. So the build images workflow builds our Docker images, which I talked about in the Docker workshop. And this is manually run. So this is using the workflow dispatch event that I talked about. So if I go here, there's different arguments. So you can choose what branch that the CI fetches from, and then you can choose a name of the image. So that's called the tag in Docker. And what this will do if we go to the code itself, what this does is that it takes the Docker file itself, and then there's an action that Docker created to build and push that image. So this is a bit more complicated, but this pushes the base image, the local base image, and the dev image for ARM64 and AMD64. So this is for like Intel and AMD CPUs, as well as the Raspberry Pi and their ARM CPUs, or Mac also has ARM CPUs. And there's some caching that's involved just to speed up the process. However, it still takes, if you need to run this from scratch, almost 3 hours. So it does take a while. The GitHub's computers that they offer for free are not super powerful. Another thing that I just thought of is there's very few instances where you have to write CI from scratch. It's more than enough to just understand like how to read through this file and understand this diagram. Because when you go to create a workflow, like a new workflow, there's some pre-built templates that you can see. So if you like search for Python, if you want to write a Python test, yeah, this is a pretty generic one, Python application. So it will give you this already. And this is pretty similar to the one that we created, pushing to the master branch. It'll set up Python, install dependencies, and link with Flake8. So just knowing how to read through this and adapting it to your needs is usually more than enough. Okay, get out of here. Right, so we talked about the build images workflow. The next workflow is a test workflow. So this runs all our ROS tests. This includes the unit tests, which is named Vulkan test if you look in your PR, and a bunch of different linters. And I've just listed here what languages each linter targets. So some of them might be relevant to you, like if you're running Python, MyPy and ClangTidy, MyPy and Flake8 is the most relevant to you. If you're on network systems, and the C++ linters are most relevant to you. But that probably means like if you only change C++ files and a Python linter failed, probably there's something that went wrong with the linter, so you can rerun the failed test. We have a couple of to-dos for this. So right now, we haven't created integration tests across the different repositories, or sorry, the different packages. So that's something that Jay's working on. And as well, Vulkan test only tests everything that's on ROS. So that does not include the website. And that's something that John's working on in the coming month, just setting up some tests and CD for the website. So remember, CD means being able to take the code that's on our repository and publishing it to the internet for everyone to access. One more advanced feature that we're using for this test workflow is a custom action. So if you remember, steps can either be run, so you can run whatever CLI command that you want, or it can be uses. So before, when we're talking about uses, it refers to a repository. Another thing that you can do is give it a local path. So you can define a custom action inside your own repository. So we do have two custom actions in our repository. We have the running container custom action as well as the docs lint. Just briefly talking about the running container action, this runs all our Docker images and then runs the script inside the Docker images. And then lastly is our docs site workflow. So new to Sailbot Workspace is we're publishing or deploying our website directly from Sailbot Workspace. So the different jobs that are in here, by the way, you can find this diagram if you go into the Actions tab, and they're for each of these different jobs. So for doc site, you can click on any one of these, and then it'll give you this diagram of dependencies and jobs that are running. So for that, there's a job for building the docs just to make sure there's no syntax errors. There's a couple different markdown linters we use. Markdown lint and markdown lint check are from the marketplace. So this is another resource that you can use. You can search for different actions that people have made here. So for instance, if I want, there's probably one for Flake8. There's an action that can probably do Flake8 and PyTest and whatever you want here that you can probably take a look at. And then it gives some examples of how to use it. So these two are just found on the marketplace. They're ones that other people wrote, but this last one is actually something that Eric wrote, which was very cool. Again, this lives in, where's my tab? This lives in .github actions docs lint. So here we're specifying this custom action. We want to run this script, and this script is also defined in here. Okay, and I think that brings us to the end of this presentation. Thanks.
There's another thing, isn't it? Like, so the linters and the build test may actually, so in some of our, in the code for Sailbot Workspace, we have, it's been specified to not like go through some of the repositories such as virtual Iridium. So we don't want to like do unnecessarily go through virtual Iridium repository and unnecessarily lint or like do any unit test because it's not relevant. So you can also specify avoidance, like specify where to not go. So that's another interesting feature as well.
Oh, also one thing, I just want to show you the doc site in all its glory in deploying the different docs versions. So what happens right now is if you create a PR and you publish that PR, there will be a new version on the doc site for that. So if you go here, if you hover over here, you'll see that for every single open PR that we have, there's a different version of the docs. So why we do this is in case you're making changes to your code, which also affect your documentation, you can update your documentation and the source code in one PR, and you'll be able to see, like preview what those changes look like in this version of the doc site. And this is all automated using GitHub Actions, where when you create a PR, it will create this version. And when you close a PR, it will delete this version. But for the main branch stuff, is in here in the main version of the doc site. And all these pages are actually just markdown pages, which can be found in the docs folder of Sailbot Workspace. So just following this hierarchy, for example, so we're in current project, Sailbot Workspace setup. We can go current project, Sailbot Workspace, setup.md. So you can see the raw file is the same. It's just all nice and rendered on the site, which is why we use the doc site. It's just much easier to read and interact with. Yeah. Any questions?